So let's talk about naming ions, and then we'll put it together to figure out how to name the whole compound. So first of all, we got to know the difference between a cation and an anion. So sodium, magnesium, right? These are all positive ions. All right, plus Ve for positive, and plus Ve ions, right? These are cat ions, and the T in cat looks like positive charge. And the way we name cations is basically one of two or three different ways. Normally, what we just use is the element name. So, for instance, Na+, we would just call this sodium, or sodium ion. If we had Mg2+, then we just call this magnesium or magnesium ion. So if we've just got the naked ion, right, we call it sodium ion or magnesium ion. If it's in the compound, we just call it sodium or magnesium. Well, that's not too bad. Now, the problem is, what happens if you got one of those variable charge ions? So if you've got iron, remember, iron can be either 2 or 3 positively charged. Remember, you got iron and you got copper. Those are the two pairs that you should know. And what we have to use is one of two methods. So there is the Stock method, named after some chemist called Stock, actually, and I really like it. And in the Stock method, you basically call it iron, and then in parentheses and Roman numerals, you write the charge. So you would write iron 2 or iron 3, right? So you would use the Roman numerals, so II and III, and put them in parentheses. So iron 2 or iron 3. So if you had Cu plus and Cu2 plus, why don't you go ahead and pause the video and name those two. Okay, so if you've unpaused, then Cu is copper, and Cu with a 1 positive is called copper 1, and Cu with a 2 positive is called copper 2. And I really like the Stock method. Now, this is the method that personally I would always name things, and the problem is that there is a common older method, and it's particularly used in healthcare, and we have to know the other way of naming, and I don't like it. There's one corny joke that you can actually get out of it, and I think it's just a hazing ritual, actually. I think we just make everyone learn it in healthcare because the predecessors in healthcare had to learn it, and but it's still useful. If you look at the side of a bag of flour or pasta, you'll still see this older method. So let me go ahead and explain how it works. Okay, so here's the older method, and we're only ever going to apply this to ions that have two different charges. So we're only going to apply this when there's two different charges, and the reason for that is that it does work for 3 or 4 or 5, but you have to know some extra stuff that's beyond the scope, I think, of this course. In the older method of naming, you're going to love this, you use the Latin name. So, oh yes, I heard you groan. And you change the ending to one of two different phrases. OUS or us, or IC or ick. And you use us if it's the lower charge, and you use ick if it's the higher charge. So if you've got two different charges, then you use us or ick. So you do have to know the Latin name. So I said that's why you have to only know it for Fe and Cu. And Fe is ferrum in Latin, and Cu is cuprum. And so if we were to name Fe2+, then it would be fer, and then we have to decide, is the ending the lower or the higher? So this is where you have to know the two charges. So actually, iron has a 2 and a 3 positive charge ion. So the 2 positive is the lower, so it's ferrous. And the 3 positive is higher, so it's actually ferric. And if you go to copper, you have the same thing with copper. So if we look at Cu2+, then we know it's cuprum. And the question is it the lower or the higher? So pause and think. Do you remember which one it is? Is 2+ the higher for copper or the lower? The answer is it's actually the higher. So because copper has a positive 1 ion, so the Cu2+ is actually cupric, and Cu+ is actually cuprous. So sorry, that's terribly untidy. So Cuprous. So those are the 4 ions. And if you're like, oh, that really stinks, well, those are the only 4 you have to know, and they come up all the time. So for instance, you will see ferrous sulfate added to flour, or you'll see ferrous compounds in multivitamins that contain iron. It turns out that iron, if you need it as a supplement, you either take elemental iron or you take iron 2 positive ions or ferrous ions. The 3 positive ion, interestingly enough, is a poison. So it does matter. And I'm not sure anyone takes copper in very large quantities, but it is helpful at killing bacteria and like. So I know you can add copper 2 sulfate or cupric sulfate to a fish tank to kill off the algae in it. So those are the Latin ways of naming those ions. Wasn't that fun? So this brings us on to a fairly corny chemistry joke. So the question is, what do you call this? And this looks kind of interesting. It has a bunch of Fe2 plus ions. So we called those are ferrous, and oh, it's in a wheel. So this is a Ferris wheel. Isn't that awful? So you can buy t-shirts with this on. So it's sort of one of those corny jokes that if anyone has taken an intro chemistry, they've probably heard before. There aren't that many really good funny jokes, but that is one of my favorites. Haha. So the last part of this lecture is naming anions. So we looked at naming cations. We essentially just use the element name, or if there's more than one charge, we put it in parentheses after in Roman numerals, or we do it the old way of doing it with the Latin name and the us-ic ending. So what about anions? And it turns out that anions, so something like Cl minus or O2 minus, essentially what we do is we use the element name, and so we have to know chlorine versus oxygen, and then just like before, we're going to mess around with the the ending. We're going to change the ending to IDE. So if we have Cl minus, then that is chlorine. And what we're going to do is we're going to scrub the ending. So the ending there is INE, and we're going to place it with IDE. So that would be chloride. Now, oxygen, I think, is kind of tricky because the question is, where is the ending here? So is the ending N, where it would be oxygeide? Is it En, where if you lopped it off, it would be oxygeide? Is it GEN, in which case it would be oxyide? Or is it YGEN, in which case it would be oxide? And I don't know that there's a really good way to explain what constitutes the ending other than kind of, well, if you've heard of it before, that's probably right. So oxide is the name of the O2 minus, and chloride, I think most people heard of sodium chloride, which is regular common table salt, right? So chloride just sounds right. So here's a couple for you. So how would you name F minus, and how would you name P3 minus? So go ahead and pause and see if you can come up with a name for those. Okay, if you've unpaused, then F is fluorine. Okay, and the ending is INE, so it just becomes fluoride. And P is phosphorus. That was like P because it turns out phosphorus was first isolated from P or from urine. And what constitutes the ending here? And the ending here is the ORUS. It would be phosphide. So you got fluoride and phosphide here.